Hello grade 6 children, welcome back to EDUHUNT classes. In the previous class, we have discussed about matter and the properties based on the chemical methods. Yes. So in yesterday's class, what we discussed, let's have a summary over here. Matter is based upon physical properties and chemical properties. So based on the properties, the matter is classified into two categories. What are those? Physical properties and chemical properties. Physical properties include solid, liquid and gas and the plasma, state and buoyant, Einstein, condensate. Okay, that you have, previous chapters, you have all that in your books. But now in this particular chapter called Elements, Compounds and Mixtures in your chapter 1 of Chemistry grade 6th, what do you have? The chapter 1 name is, yes, Elements, Compounds and Mixtures. So in that condition, we are going to deeply learn about chemical properties. As we discussed in the previous class, what is chemical properties and what are the, subgroups, divisions and all, okay? So in the chemical properties, based upon the chemical methods, the matter is divided into two main classifications. What are the children? There are called pure substances and one more is mixture, okay? Based upon the chemical properties, the matter is classified into two types. First one is pure substances and the other one is mixtures. Okay. So yesterday we have discussed about elements too, right? So elements and compounds are the sub-classifications of these pure substances. Okay. Elements and compounds are the sub-classification of this group pure substance. Okay. So we discussed what is pure substance, etc., etc. and all. And in that classification, we discussed about elements and compounds, okay? So general definitions we have discussed. But in the elements category, we have discussed what are metals, what are non-metals, what are metalloids, and also what are noble gases, okay? The classification of elements into four different types, namely metals, non-metals, metalloids, and noble gases. We discussed all this thoroughly in detail. Yes, children? So in today's session, we are going to learn deeply about compounds and the mixtures classification, okay? Compounds and others, the type of mixtures, homogeneous and heterogeneous, we are going to discuss in today's session, okay? So up to here, maybe you're clear with that, children? So pure substances and mixtures are division. In that pure substances, elements, compounds. In elements again, metals, non-metals, metalloids and noble gases. And in mixtures classification, it also divided into two. First one is homogeneous mixture, second one will be heterogeneous mixture. So what is the chapter heading mainly? I want to ask you children, what is the main heading of the chapter? Do you remember that? What is the heading? Come on, tell me. What is the heading of the chapter? Elements, compounds and mixtures. Okay, the chapter name itself says elements, compounds and mixtures, okay? So far you have learned about elements. And in today's class, we are going to discuss about compounds and mixtures too. Okay, children, are you ready? So in yesterday's class, I described all these things, metals, non-metals, metalloids and noble gases. Okay, so let me show you the picture in the table. Yes. So this is a periodic table and here there are some elements which are not, named yet. But now, updated version, we have all the names up to organeson, OG. Remember that. The last element, OG. Okay, organeson. This 18th element is organeson. Okay, here didn't describe. In this picture, I just selected this picture to show you the number of metals, non-metals and metalloids. Okay, we discussed now there are 91 metals out of 118 elements and some non-metals like around 24 or so including noble gases and the other 7 will be metalloids. So did you remember that, children? So in that summary, I'm going to show you this. Okay, this is a picture of the periodic table classification into metals, non-metals and metalloids. Okay, the blue color differentiates us with the metals. Okay, all the blue color ones are there now. Those all are metals. Okay, there are 91 metals out of 118 elements. Okay, and coming to non-metals. Can you see the non-metals? It is green in color. These are the non-metals and their overall, including noble gases, we can count it as up to 24 approximately. What are noble gases? Yeah, the noble gases, the last. This condition is then this last row. the group 18th element, or we can say the group 8A in the Roman number. Group 18 or 8A is represented as noble gas elements or rare gases or aerogens. Okay, all these are noble gases present towards right corner, up to right corner in the periodic table. Okay, then coming to non-metals. Non-metals. Okay, coming to metalloids, coming to metalloids. These are orange in color. Can you see them? Orange in color. Namely boron, silicon, germanium, arsenic, antimony, tellurium and polonium. These are 7 in number. Okay, so to show you, I just selected this picture for the differentiation of metals, non-metals and metalloids, children. Hope you are clear with that. Okay, coming to the topic in the element topic, we have a small subtopic over here. I want to discuss with you that, and that topic is called as atomicity. What is that, children? Atomicity. Note it down. Atomicity. What is atomicity? The name itself says there's a word called atom over here. What is atom? Atom is the smallest part of the matter. Atom is a building block of matter. Okay. So atom is grouped into some other 1, 2, 3. Let's see what is that in atomicity. Let's write the definition first of all. What is the definition of atomicity? Okay. Here we go. The number of atoms present in its element is called as atomicity. What is atomicity? How many atoms are present in that particular element is called as atomicity. Okay. The word atomicity means the definition. The number of atoms present in its element is determined as atomicity. For example, let me give you an example. He. What is He? Helium gas. Yes, helium, the noble gas element. The second lightest element after hydrogen we discussed now. That is one. Okay, helium. And oxygen gas representation in O2. Yes, and coming to ozone. Ozone. O3 representation. 3 atoms of oxygen combined together to form ozone. And all these are examples of atomicity. Okay. And in atomicity classification, we have a small classification. Let me do it for you, children. There are divided into mono, di, and poly. What is this mono, di, and poly? Atomicity is classified into 3 main categories, namely monoatomic, diatomic, and polyatomic. What is meant by the word mono? Mono means single. Yes, one, only one. If there is only one atom present in that particular element, it is called as monoatomic element. Okay? And if there are 2 atoms in that particular element, we call it as diatomic element. Okay? You can easily see the number, don't worry. Okay, children? And what is mean by polyatomic? Poly means, the word poly means many. Poly means many. Means let's say more than 2. Okay, maybe more than 2. So that condition and that element is said to be polyatomic molecule. Okay, more than 2. Okay, so for clear classification, let me draw you one flow chart for you. Yes. So atomicity, atoms are classified. Atomicity. Okay, in atomicity we have classification based on the number of atoms present in the element. Okay, children. So let me add here one by one. The first classification is monoatomic, as we discussed, monoatomic. And the second one is diatomic. And the third one I said, poly. In that poly, I'll just classify 1 or 2, 3. See what are those. Triatomic. Okay. And let's write tetratomic. All these are some words. I'll define you what are those, okay? Next comes octatomic. What are all these names, ma'am? You are confused? No, you know the names of this in the math? Yeah, mono means 1. Okay, mono means 1. Single atom present in that particular element. Okay, di means 2. Coming to tri. Tri means 3 atoms present in that particular element. Okay, tetra means 4. Okay, then what do you mean by octa? Octa means 8 in number. Okay, so poly means more than 2 na? These 3 we can write in the condition of polyatomic. Okay, mono, di and poly. In that poly classification are divided into tri, tetra and octa. There are so many, but these 3 main I just included here. Okay children, so let me give you examples for each one of them for clear understanding. Examples, monatomic examples. Can you see what are the examples of monatomic? Yeah, as I said, helium gas, He. All the noble gases are monatomic because they not react with any other particular element, right? They're inert gases, chemically inert. Yeah, you can write helium, neon, argon, krypton, all that. So and so you can write. Okay, all these are monoatomic. All these are monoatomic. And coming to diatomic, what is meant by di? Di means 2 atoms. There should be 2 atoms present in that particular element. Okay, examples for this is oxygen. Oxygen gas is combined with 2 oxygen atoms. So, O2 is representation. Coming next is chlorine gas, Cl2. Okay, so on. We can write for diatomic. Triatomic. The word tri means 3. The word tri means 3. So, let me write here triatomic O3. How many atoms of oxygen are there here? 3. Hence the name tri. Okay. Let me give you one more interesting example. CO2. Ma'am, why CO2? If I see O, it's only having 2, right? Where's the other one? Here goes. The C, carbon is also an atom. So, 1 carbon plus 2 oxygens gives rise to 3. Okay, 3 atoms. We have 3 atoms in the particular carbon dioxide formula. Okay, so here also it belongs to triatomic. Coming to tetraatomic, you can write P4. Phosphorus exhibits with 4 atoms combinedly grouped together. And coming to octa, we can write S8 sulfur molecule. It's bonded with 8 atoms. Okay, the stable one. We can write like this. And coming to the poly one, I just want to add one important thing here. Poly, all these 3 are grouped into poly, right? Polyatomic. Yes, I said the word poly, right? So, polyatomic examples can be, I discussed O3, P4, S8, and also up to here, you know the names, triatomic, tetraatomic, and octatomic, right? And here the further names, we can write with the examples called B12. B stands for boron, B12. And one more interesting example is C60. Wow, ma'am, 60 atoms together. Do you have a doubt? Okay, let's see what is that. 60 atoms containing carbon. So, C60 is also called as carbon 60. Okay, carbon 60. You know, this carbon 60 is having a special name. You know, what is that name? That name is Buckminster fullerene. What is the name, children? Buckminster fullerene. Once again, Buckminster fullerene. So, carbon 60 has having a special name that is called as Buckminster fullerene, and this carbon contains 60 atoms together with a hollow special, shape like, hollow shape like, soccer ball, children. It represents like that, okay? It having a special shape with, hollow structure, okay? Very big structure containing 60 atoms, okay? Here, the C60 is special indicated and the name is Buckminster fullerene and it contains 60 carbon, okay? 60 atoms are present in that particular carbon, okay? So, here, this is the presentation of the atomicity, children, the classification and all. So, let me show you diagrammatic one. Yeah. This is the atomicity classification. Here, H2. What group it contains? What is the name, the classified name here? We can write down. Can you tell me what is the name? We can write down here. If it is H2, hydrogen gas H2, it is having 2 atoms. The what is the name here? How can you write the name? Classification? Yes, diatomic. Because it is having 2 atoms in the particular diagram. Okay. And here, can you see nitrogen? Nitrogen N2. N2. It is also di. And coming to oxygen. Yes, oxygen also diatomic. Coming to phosphorus. Just now we discussed. Phosphorus P4 no? Tetra. And sulfur, which means 8 means octa. Octatomic. Okay. So here 2. P4 O2, P4 S8. Okay, these are the examples of representation of the particular atomicity. Can you see the children how the 2 hydrogen atoms are bonded with a single, see, hydrogen atom and hydrogen atom are bonded with a single bond. Okay, here if you see nitrogen is bonded with triple bond. One here, nitrogen is like this with triple bond, and oxygen is with double bond. 2 atoms of oxygen come together with double bond. And phosphorus with 4 different atoms and each with a single bond. Sulfur is also 8 atoms with bonds in between. Okay, this is all about atomicity. Hope you understood. And now we are going to discuss about the topic compounds. Okay, so far we got into the topic elements. We discussed all about elements. So the second most important topic in this session, in this class, in this chapter is compounds. We'll go into that, children. Okay.